In software engineering, we are discussing chapter number 19, Quality Concepts. Why do we need quality? Before that, there are certain headlines we need to discuss. CIO magazine said, let's stop wasting $78 billion a year. Why was that? Because the businesses are spending money on certain thing which is not supposed to be spent, where they shouldn't spend. Information Week, they also had the same concern. The concern was that the buggy software, the problematic code, the defective code, this is accounting for more than 45% of the computer system downtime. It is costing a huge amount, about $100 billion to the US companies, because they are losing the productivity, the repairs, and these are all the companies are spending. What about the customers? If the customers get angry or they are dissatisfied, how to cope up with that? So look into this matter was inevitable. The kind of bad code, the kind of non-tested code, the kind of buggy software. So what is actually a bad software? What is bad in this bad software? What is bad? What does bad means? So the experts are saying that if a programmer is writing a 1000 line of code, 3 to 4 defects per these 1000 code will make the program perform poorly or unsatisfactorily, or you cannot rely on it, and it will be a buggy software. The vendors are spending half of their budget, development budget, to fix the errors while they are testing it. So the errors are so much, they are not following the requirement model or the design model or the proper software engineering practices, and finally the software is not to be used or is unsatisfactory. In 2005, Computer World said that this bad software is to every organization. That is, the computer downtime because the software is not working, the data gets corrupted or even lost, the sales are not picking up, and the most of the money and effort is going into the support and maintenance, and finally this customer is not satisfied. In 2006, InfoWorld, they also said the same thing. They said that the distressing state or the sorry state of software quality, and they have said this is the quality problem. That is, we are feeling sorry. Why? Because the quality is not there. So here comes the word of quality. Not only in the software field, but everywhere. So as this emphasis or the thought or the concerns over this quality grew, there were so many people, around 100,000 white collar professionals. They indicated that the quality engineers are the most happiest, especially in America. And the blame game was taking place. Everyone was blaming every other. For example, the customer. Customer was blaming the developers that you are not making a good software, you are using sloppy practices, you are giving us the low quality software. So you are not quality assuring, no quality is checked. The developer is blaming the customer that you want the software in no time, that is irrational delivery dates you are giving, and you are just changing, you are coming up with different requirements. So how can we give in that time without validating, but we have to give. So now the problems are there. So the blame game is taking place, and nobody is talking about, or nobody was talking at that time, was about quality. What is quality? Now you see a gentleman, he has a bike. Now he wrote a book, proper book. And what he said, he is Robert Persing. And in a very good book, mystical book, in Zen and the Art of Motorcycle Maintenance, he commented on quality. And what did he commented? He said, quality, what is this? Everyone knows it, but nobody knows it. That is, the quality is self-contradictory. Some things are better, they may have good quality. Sometimes some things are bad. We can say that they are not having good quality. But how do we say what is quality? We just say this thing is good. That is not all. If something is good, is that only quality? But if you can't say what is quality, how do you know it? But you know that it exists. You don't know about quality, but you know about quality. Does it exist? If no one knows about quality, what is the quality there? Why do we have quality? If it is not existing or existing, how can you grade the quality? Some things people pay a lot, sometimes people don't pay for something. Does it relate to quality? So some things are good, some things are bad. But what is this badness or goodness? So we are just going round and round and round. Finally, he just said last thing, what the hell is quality? What is it? Now here comes quality with different thoughts. Now he is David Graven. He was from Harvard Business School. He suggested quality is not just one thing, it's quite complex and we have to think from different perspective. That is, he said it is multifaceted concept. And he described 5 different points of view. So he started with the transcendental view. And this transcendental is that quality is something in a product you can easily recognize. You may not be able to define. For example, a beautiful girl, you say, oh, how good she is. Or a handsome man, the girl will say, oh, how handsome he is, how good he is. But what is the handsomeness? How do you define it? So some things you see looks good, but how to define it? What about the user view? The user view is that user wants something to be done. He buys something for his purpose. Now, if his user goals are met, it is easily can be concluded that this thing exhibits quality. What is the manufacturer view? There are certain specifications on which or through which, on the basis of certain these issues, the product is being made. If these specifications are being fulfilled, then we say the product is exhibiting the quality. This is the manufacturer's view. That is what we have decided, we have made. This is the manufacturer's view. What is the product view? See, if product is solving certain problem, quality has, if certain inherent characteristics should be there in product, and if that all these functions and features are there, the quality is there. This is the product aspect. Okay, the functions and feature it is fully fulfilling. Then coming to value-based view, that is how much user is going to pay for it. If the user is paying without thinking, then it is showing good quality, the product. Otherwise, if the user is not paying, may not be a good quality for the product. So there are 2 things, quality of design and quality of conformance. First is quality of design. The quality of design is what the producer or designer has decided and what the product is fulfilling. That is, maybe the user might have decided what are the grade of materials he is going to use, what are the tolerances for different parts of the product, what is the performance specification being decided earlier that the product should give. If all this is fulfilling, then we say this is related to quality of design. For example, a bike, 150 kilometers, the result is 150 kilometers. So quality of design is there. So the design quality of a product increases if the product is fulfilling the specification which were made earlier, that the product is meeting all the specifications. But in software development, the quality of design is the degree to which the design meets the functions and feature, which is specified where? In the requirement model. In requirement model, user specification or the SRS is being made, and function and feature are solely dependent on it or it can relate to it. Then we say, oh yes, because all the requirements are fulfilled, then the quality of design is achieved. This is with respect to software. Quality of conformance is that you have certain design, you have certain requirement, and the degree to which when you actually implement, whether you have followed the requirement and thereby the design, this is the quality of conformance, that you have actually adhered, you have actually followed, and you have actually had a base from design and requirement, and you actually made the content or the software or the product or the website or web app or any system which is conforming to the design and requirement. This is called the quality of conformance. So Robert Glass, he said, the user satisfaction is all about quality, but it comes from where? When the product is compliant, the product is fulfilling what is being decided. The quality is good, people are feeling good, and the product is delivered before time or on the time and within the prescribed budget. When you combine all these three, then the user satisfaction comes. So quality is actually important. But if the user is satisfied, he is happy, he is delighted, nothing else matters. Whether it be software, whether it be any other product. User is satisfied, the product is good. DeMarco states, this product quality is a function. Mathematically, if you see, product quality is a function that how much it changes the world for better. That is, how do you change the world? Because every single human being, if they are changed for better, the world will change. If you're getting $10, maybe you are getting $100, the world is better for you. Okay. So the product quality is a function of how much it changes the world for better. And as I said, if the software or a product is good and if the user is satisfied, he is lenient enough. He will tolerate any kind of reliability issue or the performance issue if it comes sometime. If microwave, washing machine, dishwasher, these have changed the life. But even some problems comes, the user won't be that much worried because it is benefiting the user in a great way. Okay. So these are certain quality aspects before we go to actual quality. So how do we define a software quality? How do we decide what is software quality? So this is a definition and it has some words which we need to understand. An effective software process. What is effective software process? We'll just see. Applied in a manner that creates a useful product. Again, useful product. So the effective software process applied in a manner that creates a useful product. So effective software process and the useful product that provides measurable value for those who produce and use it. That is, it provides benefits or revenue or measurable value to the producer and the user. So three things are here and we will discuss all these three. This is the software quality. So the definition has three key points, important points to ponder upon. What are these? An effective software process. So an effective software process is actually, we are talking about a software development lifecycle. So the effective software process is establishing a background, is establishing a base or infrastructure that support effort being applied to build a high quality software product. So when you have an effective software process, that is, it is bound to give you a high quality software product. Okay. So here the software engineering practices, those which allow the developer to analyze the problem, design the problem, solution to the problem, to build a high quality software. So all the key to the quality is the umbrella activities like the change management, the technical reviews, the code reviews, so many things, validation, verification, and all the software engineering process applied in a way which has been decided by different SDLCs in different process in different path. They followed properly, then only you can get a quality product. A useful product is what? Which gives everything what is desired. That is, I am saying that this definition has three main key points. So I am taking the second point, which is a useful product. If a useful product is giving you content, it is giving you function, feature, but how it is giving? In a reliable way, in an error-free way, and what user desires. All these things are being given to the user. The useful product is what? Implicit, explicit. That is what you have said you are getting, and what you haven't said, you are also getting that. So the implicit, explicit requirement, they are also fulfilled. So this is absolutely a high quality software along with the content, function, feature by adding value. So the high quality software, it provides benefits to everyone, every stakeholder, especially the software organization who has built it and the end user who will use it. The software organization, how they are getting the value. The high quality software requires the less maintenance effort. Bugs are less, so fewer bug fixes. And the customer support will be less because the software is working well. So reduced customer support. So this will add the value to the software organization. This is how this is adding value. A high quality software will add value. How about the users? User, because the software is being made for them, and if it is not buggy, it is not bad, then it will expedite their business process. So what is the end result? Everyone will be benefited. The product revenue will be good. The greater software product revenue will be there. The profitability to every stakeholder, to everyone who is involved. And finally, the improved availability of information crucial for business, because the software has been made to solve certain business problem. Garvin's quality dimensions are there. Now this applies to software also and other fields also. And Darwin, he suggested certain dimensions. He also said that everyone has to have a multi-dimensional viewpoint, because quality is just not to be defined in one way. It has to be seen in multiple ways. It starts with the assessment of conformance, that what we have decided, have we made it? The specifications, the requirements, all this has conformed or followed. And finally, the transcendental, or you see, the satisfactory view. Something should look good. So Garvin's 8 dimension of quality, how it can be applied to software, is the first is the performance quality. That is, does this software provides everything like content, function, features, but from where? From the requirement model, from the software requirement specification. What has been agreed upon by the developer, by the stakeholder and the user, everyone, has it be fulfilled? Feature quality is the feature which delights, which fascinates the first time user. They says, oh, what a good software it is. Reliability is all the functions are delivered, but are they delivered without failure? When we want the application, when we want the system, when we want the software or the website or a web app, is it available? Conformance means there are certain companies standard, there are some certain standards by different agencies. Are they fulfilled? For example, something which has been decided. Did this software has a conform? For example, user interface you are making. Now there are certain design rules. For example, menu selection or data input. There are accepted design rules. Have you fulfilled that design rules? Durability. Durability is, can we change the software or the system without producing more errors or unintended side effect? If some audio call you have fixed, the problem has propagated to the video call also. Serviceability means that what is the shortest period of time and how long does it take to change the software, correct the software, maintain the software. So Douglas says here a very interesting thing. He says that if you think this thing can go wrong and this thing will not be going wrong. So if something which you have decided will not go wrong, and if it goes wrong, then there is no possibility of repairing it. It will be impossible to repair what you have already said will never go wrong, because you have not decided for it, planned for it. Aesthetics. Aesthetics is elegance, unique flow. That is, you cannot quantify it, but you just know that this thing is good. This is maybe experience, or something delights you, something makes you happy. As I said, aesthetics is all about looking good. You want to eat something which is good, looks good. There are certain prejudices, perception. If somebody comes to you and already someone has said that this guy is not good, you will always think that he is not good. So you already have a prejudices, like the different kind of religion, different kind of say caste and creed. All these things are going on because people have prejudices. But every religion, everything says the same thing. For the betterment of people they work. So these are prejudices everyone has for every other. This is same for quality also. That is, for example, I'll just give an example. If a vendor has already made a poor software, when he makes another software, you will be prejudiced that no, he will not make a good software. If one vendor has made a very good software, then even if some problems are there, he will accept it with warmly. So Garvin's quality dimensions which you see here are quite soft. That is, quantifiability is not there. It is just he has said, and people are accepting it. But we need something hard. That is, we need to categorize these into broad groups. That is, factors in these dimensions which can directly be measured. For example, the defects which are uncovered, which are found during the testing, and the factors that can be measured only indirectly. There is no way we can directly measure it, but still we need to measure it. So this is the hard approach. All the dimension he has given has a soft approach. McCall's quality factors. Now McCall, his colleagues Richards, Walters, they proposed categorization of different factors, attributes that affect the software quality. So actually they wanted to define the software quality. So there are certain factors that are affecting, and they focused on three very important aspects of a software. The first one is the operational characteristic, that is the product operation. When a software will be used, what are the characteristics, features, functions? Ability to undergo change, that is product revision. If you change the software, how does this software change easily, or what are the effects? Finally, the adaptability to new environments, that is product transition. So all of these major category, they have underlying different attributes. So this is the triangle, McCall quality factor triangle. In product operation, we have certain factors, revision we have certain factors, and product transition, these are certain factors. So all these factors were defined by McCall. What are these doing? Why are they important? For example, the product operation. Let us start with correctness. So correctness is extent to which program satisfies the specification and fulfills the customer's objective. That is, if you have defined or decided certain specification, the degree to which this software is conforming to this specification. Reliability, that is extent to which program can be expected to perform its intended function with required precision. That is the function which is being defined, it is doing, and it is doing it reliably with required precision. We'll talk about reliability and availability later. We'll give a proper mathematical definition. But for now, reliability, that we can rely on it. Proper function. Efficiency, see, it is going to work on some computing device. That computing device will have certain resources. That is how efficient this program is going to use the system resources, the computing device resources. This is the efficiency. Integrity. Integrity is if someone like he is unauthorized, if he is want to enter access, how do we control his access as far as software and data is concerned? Access. Usability is when a novice or a new person is using the software, how much effort he should put to learn, operate, the input he wants to give, the output he wants to interpret, because input output are also very important. So learning, operating, and the input output interpretation, usability. Maintainability is if some problem is there, some error is there, how to first locate it and then to fix it. How much effort is required? That is the maintainability. There is a whole part of software engineering, that is maintenance. Then comes the important part, which is flexibility. That is, you want to modify a program which is already operational. How much effort is required to modify this operational program? Testability is the effort required to test a program, test a software. Portability. Now, there are different hardwares and software platform. Now, you want to transfer or do transition, perform transition from one configuration to another. How much effort is required from one hardware to another, one configuration to another? This is the portability of McCall. And this comes under the product transition. Reusability. Do we have any part or parts of the program that may be directly reused in other application? Reusability. Interoperability. That is, if one system is there is another system. How much effort is required to interface them and to couple them? To means combine them, interconnectivity. So all these things we have seen, but there is one consideration, that the matrix, because we want numbers. So all these different McCall quality factors, they are good to know, they are good, and we can also easily find the quality. But in order to find the mathematics or the numbers, we may not be able to get it directly. But this gives a quality input for us as a software people. ISO 9126 quality factors. This is ISO IEC 9126. So ISO is International Organization for Standardization. So ISO, this standard, this was developed in order to identify what are the key quality factors, attribute, features for a software. So they divided it into major parts, and all these parts are again dependent on certain factors. For example, if you take FERPs, if you take McCall, all these are all about showing the quality, representing the quality and defining the quality of the software. So when it comes to ISO 9126, the major thing is functionality. Now here, are the required functions available in the software? That is the degree to which the software satisfies the stated needs. The software is made for America. Is it doing work for, say, China? Don't know. So this is the functionality. Suitability, accuracy, interoperability, compliance, security. If degree is about 100%, 90 is achieved. So now we have a degree here. The degree to which these specifications are satisfied, the work being needed. Then the reliability. The amount of time, the span of time the software is available for use. If a user wants to use the software, is it available? And without any failure? So the underlying factors here are maturity, fault tolerance, and recoverability. Usability. Usability is the software easy to use? That is the degree to which the software is easy to use. If someone comes, he is able to understand the software, learn easily, and then operate on it, to work on it. So these are the usability. Efficiency. The degree to which software makes optimal use of the system resources. That is, the software is going to work on some certain system. The time complexity, the space complexity, the time behavior, and the resource behavior. These are the two factors which are defining efficiency here. Okay. So the system resources have to be used very efficiently. Maintainability. Now, there may be some problem, bug fixing. That is what we call in as a repair of the software. So here comes analyzability, changeability, stability, and testability. Portability, one environment to another. You want to change the software, transform or transfer the software application. So here comes the adaptability, installability, conformance, and replaceability. So all these are the ISO quality factors 9126. But still this gives you a very good idea about quality for everyone. But there has to be some measurement criteria. Until we measure, we will not be able to know the numbers. So though things should not be, subjective. Okay. So ISO 9126 quality factors. Either FERPS, McCall or ISO 9126, all are for quality. Targeted quality factors. So whenever we talk about quality, McCall or any other, qualities presenting standard, they are identifying certain thing and they have to define also. So just by knowing that these are McCall factors, learning and mugging up is not important for us. I'll give an example. Let us know what do we do actually. For example, in McCall triangle, we have a usability in product operation. If your boss tells you, okay, need to check the usability. How do you check it? In order to check usability, that okay, tell me that this is the user interface where user is going to interact with the application, software, website or web app. Now you have to review and assess the usability. Usability is a quality factor. So how do you do it? In McCall, the usability consists of understandability, learnability and operability. When we learned the McCall, I told you. So all these three things you have to assess. So in order to do the assessment, in order to conduct the assessment, you need to address specific measurable attributes of the interface. So measurement is very important. For instance, the first thing comes here for usability is intuitiveness. That is the degree to which the interface follows expected usage patterns so a novice can use it without significant training. If a new person comes, how much effort is needed? So we need to ask certain questions. Intuitiveness is all about this. So the first question can be, is the interface layout conducive to easy understanding? Have you made or that user interface is made like this? Are interface operation easy to locate and initiate? Have these operations being hidden? It is hard to find them. Does the interface use a recognizable metaphor? A event, a content, an icon, is it recognizable? Or it is something out of the box? Is input specified to economize keystrokes or mouse clicks? That is, for any word, say you need to use keyboard 5 times. Can it be made 2 times? That is, the effort has been reduced. The efficiency is better. Have they made it easy? Does the interface follow the 3 golden rules? Now 3 golden rules for interface, UI or UX, I'll talk about that later. But for time being, you need to understand that usability testing is all about being useful, findable, accessible, usable and desirable. Does aesthetics, the beautifulness, aid in understanding and usage, or does the aesthetics creates a problem? The second thing comes for usability testing of user interface. is efficiency. That is the degree to which operation and information can be located or initiated. The operation, function, feature, how are they located? Can it be initiated easily? What is the efficiency? So the question you are going to ask is, does the interface layout and style allow a user to locate operation and information efficiently? Does the layout is consistent? Or is the novice user able to use it without problem, efficiently? Operations are clearly seen, information is very visible. Does the interface layout hiding something? The style is not consistent. Can a sequence of operation be performed with an economy of motion? That is, for a special word, you have to do 10 operations. Maybe it can be, pressed into 2. Are output data or content presented so that it is understood immediately? Have hierarchical operation been organized in a way that minimizes the depth to which a user must navigate to get something done? User is lost or he gets everything. The next thing comes is robustness. The degree to which the software handles bad input data or inappropriate user interaction. Now user is a king. He can do whatever he wants. Sometimes wanted means knowingly, unknowingly. So does this software handle these things? Will the software recognize the error if the data values are at or just outside prescribed input boundaries, boundary values, analysis? More importantly, will the software continue to operate without failure or degradation? Some number is given, 360. It can go up to 360, some angle. What are you putting 361? What is happening? 359.99, what is happening? And even if it happens, is there graceful degradation? Or you get about retired, done. Will the interface recognize common cognitive or manipulative mistakes and explicitly guide the user back on the right track? If something bad happens, is the user guided to go to that position where he can restart? Does the interface provide useful diagnosis and guidance when an error condition is uncovered? For example, some error code. Error will happen. But does it provide, oh, this has happened, this is the error code, now you must follow these? That is, a graceful degradation or a failure tolerance is there. This is called the robustness. Okay. Then comes the richness. The degree to which the interface provides a rich feature set. How much feature it is providing and a useful feature. Can the interface be customized to do the specific needs of a user? Can the plugins be applied? Is something not available in that application which a user really wants? Does the interface provide a macro capability that enables a user to identify a sequence of common operation with a single action or a command? For example, if you go to GIMP, very popular image processing software. Now, there are multiple operations you have to do, but these operations can easily be clubbed into a batch. And for an image, you just apply this batch, all these operations can be done easily. So is something of this sort is there? If I answer to all these questions, most of the questions, majority of the question is yes, the user interface is highly likely to show a high quality, a good quality, a better quality. I hope you got the idea how user interface can be checked. This is done for all of others. The cost of quality. Everything cost, even the quality cost. So I'll give you a very good sentence. We know that the quality is important, but it costs us time and money. Time, effort, money, resources. Too much time and money to get the level of software quality to the best possible. Do we really want that? Because achieving a 100% quality, you need to put all the resources, money and time, everything. So there are two things which comes. Quality has a cost. That is, in order to achieve quality, we need to spend effort, time, etc. But there can be a lack of quality. There can be quality which is not there. So what is the cost incurred when a low quality software is delivered? So which cost we need to be worried about? Cost of achieving quality or cost of low quality software? So cost of quality, we can divide it into three main key players. First is prevention, appraisal, and failure. That is, we know the maintenance. So, giving you an analogy, preventive maintenance and corrective maintenance. In between also something comes. I'll discuss about all these figures, but before that, the cost of quality is prevention, appraisal, and failure. What are the prevention costs? That is, we want to prevent something to happen. So, cost of management activities. First, we have to make a plan, and we have to do all the quality control, coordinate them, plan them, manage them, and the quality assurance activities. Then the cost of added technical activities, because if you have developed some requirement, you have developed a good design. So, all the coding and testing should be done according to this. So, there will be added technical activities. All these test planning, because testing is an important factor, there will be cost. And in order to do all this, you need trained people. So, in order to train, there will be cost. I hope you got the idea of prevention cost. Then comes the appraisal cost. Now, appraisal cost is you want to see and you want to find if something is bad or good. So, this includes activity to gain insight into the product condition the first time through each process. You want to see, you want to appraise, you want to find out, verification, validation. That is, you need to do the technical reviews. For that, a cost will be there. So, cost for conducting technical reviews will be there, comes under the appraisal costs. You need to collect the data. You need to collect the metrics. You need to analyze them. You need to find facts and figures about that. That is the appraisal cost. So, data collection and metrics evaluation. Then to test and debug. Again, there will be a cost which are related to it. These comes under the appraisal cost. Okay, let me just complete, then I'll come to these figures. I'll discuss about each of them. Because the cost, how does it increase? Where to do this? At which point we have to stop? Failure cost. See, if something fails before the delivery of the software, after the delivery of the software, there can be failure, no doubt. So, what are the failure costs? Incurred, how to deal with it, how to categorize them, shipping, before shipping, after shipping, between shipping. So, this failure cost can be divided into internal failure cost and external failure cost. What are the internal failure costs? These are incurred when you detect an error in a product prior to shipment. Before delivery, the error or problems or bugs you just found. So, internal failure cost, what does it include? First of all, now you have errors with you. So, the cost required to rework or correct an error. The cost that occurs when the rework is done, but it generates more error. How to mitigate with that? The cost associated with the collection of quality metrics, because you need to assess the modes of failure. The cost will be there. So, this comes under internal failure cost. But these are the numbers you can easily find out. But what about the other factors? There are other factors also of internal failure cost. About the effort and the software team. How do they feel? The external failure cost, they are associated with the defects found after the product has been shipped to the customer. You already given it. Now the user is facing problem. He will come to you for complaint resolution. It may be replaced also. Return will be there. They will be wanting support, and there will be labor cost, workability cost, who is going to work on it in the warranty work or maintenance time. So a poor reputation and the loss of business will come under the external failure. This is not thought many a times. But a company, the poor reputation, and then the business will be lost. No one will come to you. They'll say, oh, no. They provided a product that was not good. This comes under the external failure cost. So a failure cost will be internal and external. So this, let me tell you about these figures now. Relative cost to find and repair an error or defect increased dramatically exponentially as we go from prevention to detection to internal failure to the external failure cost. If internal failures are there and you are able to prevent them, it's good. At appraisal time, it's better. But if you need to correct it after the delivery, it's worst. worse. Now see these graphs. Okay, on the left, that is y-axis, we have total cost, x we have quality improvement. At the time of appraisal, it's good. Prevention, yeah, okay. Internal failure, oh my god. And external failure, oh my god, external failure is costing too much. So I hope you got the idea. As a software people, you need to appraise it, find out, verification, validation has to be done on trying to prevent the errors before they can come. And even if it comes, you need to do the internal failure and mitigation, and then the final. So at the requirement time, design time, coding time, testing time, maintenance time, you see the requirement time cost, you see the maintenance time cost, and just divide them and find out how much times you need to work. So this is a very good graph. You can have zero error, you can have some error. Getting zero error will cost you too much, but having few errors may work. So there has to be some optimal quality level. On the left you see y-axis cost, on the right you have the percentage of defects. So there is a sweet spot. This is the total cost of quality. There has to be optimal quality level. You cannot have the thousands of error, and you cannot have a zero error. You need to be somewhere in between. This is the optimal quality level. You see, the cost is also okay and the defects are also okay. You cannot get a perfect quality, but you don't want even to have a non-quality. So there has to be some way you have to be in between. But those failure which are hurting people, killing people, please try to go for a perfect quality. Risks. When we make a software and when the software is responsible for people, that is, we already seen about people betting their jobs, comfort, safety, entertainment, their decisions, even their lives on computer software. So we need to be very sure that the software is right. In medical field, in aviation, in maritime, everywhere we have software. I'll give you an example and just imagine what can happen. Throughout the month of November 2000 at the hospital in Panama, 28 patients, this is the hospital, Gorgas Hospital. Here 28 patients received massive overdose of lethal gamma rays during the treatment for different kind of cancers. And the month following, 5 of the patients, they died from this radiation poisoning. And the radiation poisoning, 15 others developed very serious complication. And why this was happening? This is the example of a bad programming. So what caused this tragedy? Errant software can actually kill you. So a software package developed by a US company, and it was modified by a certain hospital technician to compute the modified dose of radiation for each patient. And 3 Panamanian medical physicists who actually tweaked the software to provide additional capacity were charged with second-degree murder. Second-degree murder. So you can imagine what can happen if the software is not good. The US company also faced serious litigation in 2 countries. So poor quality led to risks. Some of them very serious. Killing people, killing us. So software can kill you. As a software developer, you need to be very careful about this thing. We always have a hierarchy in companies. So we have a management, big boss, then people who decide. Then comes the moderate level people like the program manager, program leader, and software coder, tester, etc. So software quality is influenced by certain things like the technological decision. But more than the technological decision, the software quality is affected, influenced by the management decisions. What management are taking different decisions. Are they wise? Are they rational? Are they legal? Right? So those people who are actually taking the decision are very different from the technological decision. So it can be for good, it can be for bad. Even if team is better, software team, the management decisions influence. The project leader, for example, they make certain decision, and that can good or bad impact on product quality. I'll give you a certain example. Estimation decisions. So how do estimation decision, they affect the software quality? A software team, it may not be, that is, I'm talking about the moderate level people. So they may not be that much involved in estimating the delivery dates and overall budget. Only the big bosses, they decide. And when they're asked, the team will just conduct a sanity check. Whether these delivery dates and milestones being given in front of them, are they rational or not? Are they good or not? Means this is just a sanity check. No mathematics, no computation. Just say, oh, it seems okay. But when the actual scenario comes, when the pressure of delivering the software comes, they accept the unrealistic, not achievable delivery dates. This happens in almost every software, because now the delivery dates have come and the budget is over exceeding. So now the team takes shortcuts, and when you take shortcut, product quality is bound to suffer. So this is how estimation decision affect. Scheduling decision. Schedule means what will happen when, after which, and what should be the project plan proper. So a software project schedule, when it is made or established, tasks are sequenced. They are dependent also. So they are based on dependencies. If something will be done, then other thing will be done like this. I'll give an example. For example, A depends on B, C, D. Component A depends on B, C, D. So until B, C, D is done, A cannot be checked. So A cannot be scheduled for testing or other purpose until the components on which it is dependent, B, C, D, are fully tested. So many cases, pressure forces, that is the delivery date, the budget, all these forces A to be tested even before B, C, D are being done completely. We may use stub, the seams or hooks. So this can be done. But A may have those defects because when it is combined with B, C, D, that is not checked. So these errors, bug, problems will be only uncovered when B, C, D will be combined. So they are discovered much later. And you know the consequences? Quality will suffer. Quality will degrade. Now coming to risk-oriented decision. The top bosses take certain decision, and what they normally do, as everyone does. See, no one says they are going to die, but everyone dies. For example, if you want to go from, say, place A to place B, have you ever thought my tire will burst, or the road will be redirected, or there will be an accident which can cause some casualty? We never do that. because we think that nothing will go wrong and we never make a contingency plan. This happens in every field, even in the software industry. We don't plan. Many teams, they would like to prefer blind optimism. That is, they want to establish development schedule under a clear assumption that nothing is going to go wrong. But when risk becomes a reality, there will be chaos, and after this chaos, quality suffers. The level of quality invariably falls. So there will be chaos. If something happens to you on road, there will be chaos. If your tire get burst, there will be chaos. Now here, Jim Maxim, he said something which everyone knows, everyone has been saying, because he said, so now it is a law. There is never time to do it right, but always time to do it all over again. That is, if you are doing some assignment and you do it hastily, quickly, but when you go to the teacher says, no, these 3 points are not, you have not done it seriously. Go and do it again. You'll go and do it all over again. But when you are doing it for the first time, you're not interested because you thought, oh, let's push it. The teacher, let us see the teacher. There is never time to do it right, but always time to do it all over again. How to achieve this software quality? There are certain ways, there are certain facts, methods, because all these attributes can only be achieved by a proper plan, organized thoughts. So management and the practice, they are applied to help software achieve high quality software. So what do we apply? Software engineering methods. This we apply. Project management techniques. This we apply. Because scheduling, PERT, CPM, quality control actions, quality assurance. So all these are applied to every work product, to whole software development life cycle. So let us start with the software engineering method. SDLC, software development life cycle, you choose prototyping, waterfall, spiral, agile, whichever you want. So the basic idea is to completely understand the problem. And then you have to design comprehensively. So a proper understanding, getting the requirement, knowing the requirement, designing it, this will be a solid foundation for construction, for coding, for testing. So when you do this, the quality of the software is going to increase, and it will increase substantially. The second thing is project management techniques. Now your project manager or the leader, there are certain ways, there are certain good ways, already laid down de facto. The impact of poor management decisions on software quality, how to avoid them. We need to adopt certain things. That the project manager should use estimation to verify the delivery dates, which are achievable, which are not unrealistic, which are so that the software team can do it with quality. Schedule dependency, that is one part is dependent on another. This has to be understood. And the temptation to go shortcut, to do it fast, to just deliver, should be avoided. Proper testing, proper verification, validation should be done. Risk planning, that is, if you plan the risk, you have the contingency plans, you have identified the risk, there will be no chaos, and software quality will not be affected. Along with this, The project planning, the management should include the explicit techniques for achieving the quality, the change management, the configuration management, the testing, different types of testing. Coming to quality control. This quality control, how do we control the quality? We need to have certain way. So this quality control are all the software engineering actions which we have learned to ensure that each work product, it can be a software, it can be a document, it can be other work product, they should meet the quality goals being assigned or being decided before we go ahead. Models should be reviewed. It can be requirement model, it can be analysis model, it can be design model. All these models, the test cases should be complete, should be consistent, and it should go through multiple reviews. So this testing should be applied because we need to uncover the errors, bugs, problem in the processing logic, in the data manipulation part, in the different interfacing, because the experienced people know where the error may lie, where may the problem may lie. So this testing has to be done methodically and with best brain effort. So the combination of this measurement and the feedback, this is done when any work product fail to meet quality. If quality is not there, just do it again. Plan, do, check, act. Plan, do, check, act. PDCA. PDCA. This is the Deming PDCA cycle I am trying to show. This is how we achieve software quality by quality control. Right? Quality assurance. Quality assurance means we are assuring that this product has quality. Who is going to assure? Of course, the top management. So quality assurance is the software engineering method, rational project management methods, the quality control. All these are applied again in a proper managed, planned way. That is to assure that the quality is there, and this will make a high quality software. So this quality assurance, it has auditing, it has reporting. So here we assess the effectiveness and the completeness of the quality control actions, right? So if the quality assurance shows some problem, identifies some problem, now this is the management responsibility to address this problem and to apply and provide the necessary resources to resolve the quality issues. So quality control, project management, software engineering, all are applied, and this is called as quality assurance. If you see here also production, baseline, system, development, release, market, all are there in the quality assurance. This is all about quality. Thank you so much. Take care of yourself.